In this example problem, we find that there's an arbitrary parcel of water at the surface of a lake, which then sinks to the bottom of the lake where the pressure is 1.5 times that of the surface. If the original volume of the parcel of water is 1 meter cubed, what is the new volume of the parcel of water at the bottom of the lake? So essentially what we're doing is we're looking at how water itself compresses itself. So we find that pressure increases with depth. So that pressure at the bottom of the lake actually compresses the water a little bit. So that's why you see that there might be a little bit of a density gradient inside of a large body of water. Alright, so since we are compressing something all around and we're looking at the change in volume, because we know how much the volume changes or how much is compressed, we're going to make use of the fact that the change in pressure is equal to the negative of the bulk modulus times the change in volume over the original volume. So our change in pressure, remember it's always final minus initial, so it's 1.5 times the surface pressure minus the surface pressure. So when we do that subtraction here, we get 0.5 times the surface pressure. And P naught here is equal to 1.013 times 10 to the 5 pascals. So I would plug in 0.5 times 1.013 times 10 to the 5 pascals for my change in pressure. I've looked up the bulk modulus of water, and remember it's a negative sign out front here, so we're going to do a negative 0.22 times 10 to the 10 pascals times the change of volume, which is already known, divided by 1 meter cubed. And that gets me a change in volume of a negative 2.3 times 10 to the minus 5 meters cubed. Now I want to know what the new volume is. And since the change in volume is negative, that means my volume decreases. So I'm going to take 1 minus, so 1 meter cubed, minus the 2.3 times 10 to the minus 5 meters cubed. And that's going to give me a final volume of 9.999987 times 10 to the minus 1 meters cubed. So we find that the change in volume is small, and therefore the final volume is not that much different than the initial volume. In fact, we have to keep many, many significant figures to really see the change.